Hello everyone, so your lesson today is all about gravity. And the first thing you could do is just pause the video and have a think, what is gravity? Okay, well, gravity is a force, as we've already seen in previous lessons. And one of the famous stories about the discovery of gravity is to do with a falling apple, and that's why I've got that picture on the screen. Gravity is a force between all objects. It's a non-contact force. And the size of the gravitational force depends on the mass of the objects. So the bigger they are, the bigger the force. So as you can see from my pictures here, between the two mice there's a smaller attractive force, and between the two elephants there's a bigger attractive force. The size of the force also depends on the distance between the objects. So the closer objects are to each other, the bigger they will feel the effect of the force. But you might be thinking, I don't feel gravity between the person sitting next to me or me and my chair. Well, we only really notice the gravitational attraction to big objects, like planets, like shown in my diagram here. The force of gravity on something is called its weight. So that's why we often draw our downwards force and we label it weight. Because it's a force, it is measured in newtons. So on Earth, Mr. Potter's weight is around 800 newtons. On the Moon, his weight is around 130 newtons. So why? In deep space, far away from any planets or stars, his weight is almost zero. He is weightless. So why? Now, hopefully you've been having a think about that. So why is his weight different? Well, it's because gravity is different in each place. And especially when you're in deep space and there's no planets near you, there'll be no gravitational force acting on you. So you will be weightless. Now, what I can imagine you are thinking is, well, we ask each other what we weigh, and we usually give the answer in kilograms or in stone or in grams. Well, actually, when we talk about weight in terms of kilograms or grams, we're using the wrong word. We should be talking about mass. Mass is the measure of the amount of a material that an object is made of, and mass is measured in kilograms. So every time we weigh something, what we should actually be saying is that we are massing it, we are finding its mass. So it's a part of our language where we're using the wrong scientific term. So now you're scientists, you have to make sure that when you are talking about the mass of an object in kilograms, you use the word mass. And if you are talking about an object in terms of newtons, you can use the word weight. So Mr. Potter, he has a mass of around 77 kilograms. And this means he is made of 77 kilograms of blood and bones and hair and poo and everything else that is inside our bodies. On the Moon, Mr. Potter hasn't changed. He's still Mr. Potter. He still has 77 kilograms of blood and bones and hair and poo and everything else. His mass has stayed the same. In deep space, Mr. Potter still hasn't changed. That means he's still made of 77 kilograms of blood and bones and hair and poo. His mass is the same. So mass is the amount of material measured in kilograms, and mass of an object is constant. Weight is the force of gravity on an object, and it is measured in newtons, and weight can change if gravity is changing. So what I'd like you to do this lesson is learn how to calculate the weight of an object. So the force of gravity on 1 kilogram is called the gravitational field strength. It is measured in newtons per kilogram. To calculate the weight of an object, you multiply the object's mass in kilograms by the gravitational field strength in newtons per kilogram. And you will take that gravitational field strength from wherever you are. So if it's on Earth, it will have one value, but if you're on the Moon, it will be another. So, for example, the gravitational field strength on Earth is around 10 newtons per kilogram. So what is your weight if your mass is 45 kilograms? Okay, so we can use the equation weight in newtons is equal to the mass in kilograms times the gravitational field strength. So my mass is 45 and I need to multiply that by 10, the gravitational field strength on Earth. So my weight will be 450 newtons. Okay, that's quite easy really. So I'd like you to have a go. So here's a practice question. The gravitational field strength on Earth is around 10 newtons per kilogram. So what is your weight if your mass is 25 kilograms? What I'd like you to do, pause the video, have a go at doing the calculation, and when you've got an answer, restart and see if you've got it right. Welcome back. So you should have done 25 kilograms times 10 newtons per kilogram. And the answer you should have is a weight of 250 newtons. If you haven't got it right, hopefully you can see where you've made a mistake. And if you've got it right, that's fantastic. You are all now ready to carry on with your task and practice more of these calculations. Thanks everyone.